Through the Noise with your host, Ernesto Glucksmann.
All right, Wendy, thanks for joining me on the show. Not meeting me at the studio because we can't do the studio these days, but
no studio.
I appreciate you stopping by and you're busy launching, I guess, two businesses. Wendy Owens, you're the founder and CEO of Hexas Biomass, and it sounds like you started another one, Biomass One. So when Charlene, started talking to you, one of the show bookers, she was just intrigued by what you can do with Hexas products. So why don't we just start there with the Hexas Biomass first? Can you tell us a little bit about what that business is about?
Yeah, so Hexas Biomass is a biomaterials company. And what we focus on is the production and use of plant-based materials, not trees, let's just say, in terms of plants, that as a replacement for wood or a substitute as well for wood and fossil fuel-based raw materials in many different applications. So for example, we can produce our giant perennial grasses, which are very efficient in terms of their land use and water and no pesticides required, also sequester a significant amount of carbon. And we can grow this on marginal soil, and we work with farmers, and so we're keeping the revenues generated in that side. And then once we harvest it, we turn it into a fiber, and that fiber, depending on the format we use, can be used in things such as fiber boards or particle board, MDF, for example, bioplastics.
MDF, you're gonna have to break acronyms down for me.
Sure, that's MDF. MDF is medium density fiber board. Okay. So it's the stuff that is the backing for different pieces of furniture. For example, they'll put a laminate on it, and it's basically crushed material that they stick together with glue, and then that becomes a board once they.
That becomes your sofa. Okay.
Yeah, exactly. Yeah, exactly. Or your chair, or your something like that, or your desk, something along those lines. Let's see. Energy production, really great for ethanol. One of the grasses that we produces 3 times more ethanol per acre than corn. So
corn. So these grasses are really thin. I saw like a picture of them. Like, how do you describe them? They're just bushy and they're thin and they kind of grow up and they.
Well, yeah, I talk about our xano grass as like bamboo and corn had a baby, because it has a sort of a bamboo-like looking stalk, but it has corn leaves, so they look like actually, because it's actually in the same family as corn. So when you look at it, it's like, okay, yep, they had a baby. There it is, because it has the structural integrity in the stalk like bamboo does, with high dense fibers. But it grows. I mean, even here in the Northwest, I grew it this summer. We were getting between 16 and 20 foot tall stalks within a 12-month period. So it'll come up around April, and then we'll harvest around September or October.
And why? So 3 times more ethanol out of like an acre of the same stuff in corn. Why is that a treat? Yeah.
So ethanol, because it has a high level of the C5 and C6 sugar, so it's a type of sugar. And because we get so much yield per acre in terms of just having these giant stalks, we'll get dry tons per acre, 20 to 25 dry tons per acre. And when you compare that to switchgrass, which is around 5, or hemp, which is around 7, we're making super efficient use of the land, and we just get so much biomass that it's a much more efficient plant to use.
And then this can be used as, like I read, can be used for like mitigation purposes. It's like a field that's gone, I don't know, it's run its course in terms of being able to produce other types of crops. This is something that can be put in its place for a while. Is that how that?
So it's called bioremediation. And so what this plant can do, in our other plant, miscanthus, is it can be planted in what is considered marginal land, which is, there's no real set definition for essentially what that land is that you no longer can economically produce row crops on that land. So, you put corn in, you're not going to get enough corn to make your money back, basically, on the investment. So what we use is that marginal land, because we have these hardy plants that can go in there and grow. But they fix nitrogen into the soil. So they'll actually add the nitrogen in the soil. They'll also add nutrients into the soil. very efficient use of water as well. And they have a massive, extensive root system, which is adding a lot of, sequestering a lot of carbon as well in the soil.
And it can break up the soil to help more bacteria or whatever
Yeah, all the good
proliferate.
stuff, exactly. And then also then, prevents loss of soil due to erosion or dust, and it can be super efficient. And we plant it once, and it can grow for 15 to 20 years after a single planting. So we're not going back in and tilling that soil up again.
Which harms the bacteria when you do that.
Which removes the carbon from the soil as well. Yeah, yes, and can interrupt with what's going on in the soil in terms of its overall improvement. Yeah.
And then, so this stuff you find farmers that need to do something with the field that's not being profitable for them. You help them, you make the case, you help them grow it. Is that kind of the part of the process with you guys?
Yeah, so the business model really is that we get supply agreements first.
Okay.
So we get our supply agreement in first for, let's say, we're going to use it as an aggregate in concrete. So we'll have to say, okay, concrete producer, we'll provide you this aggregate, and then we'll go out and find farmers within a 60-mile radius of that location. And the reason is because biomass, especially plant-based, is not dense. So you really are limited in terms of the ability to transport it from one place to another, because that lack of density makes it just simply expensive and not economical. So we'll find local farmers right there in that community, and we'll supply the plants to the farmers so they're not having to make a really large upfront capital investment. And plants, because the perennial grasses are traditionally sterile, don't have seeds, so we have to produce the plants via tissue cloning. And then we'll contract with that farmer for production at a certain level. We'll provide all the technical assistance for planting, growing, which after about the first year is just let that stuff grow, and we'll come and help you harvest it at one point in time, because it's like watching the grass grow. It's not a lot of effort for the farmers as well. We're not having them use pesticides, maybe a little fertilizer depending on the quality of the soil, perhaps a little water in the first year for irrigation to get the roots established. And then once they harvest, we pay them in a price per ton or some kind of arrangement. And that material is either pre-processed into a format that will be used by our customer, or we can just take it straight out of the field and deliver it to the customer depending on what's going on.
Wow. And then there's a lot. I was just going through your website. It was like it can feed into existing supply chains and manufacturing processes. You can just mix this pulp material into what you said, the particle boards, right? So I recently noticed that like 2x4s are getting more expensive because of COVID and other issues with price shocks and supplies and just people not being able to harvest wood. Are you finding more people interested in the possibility of using your material, mixing it in so that they can offset the costs of the wood material that they use?
Yeah, so absolutely. So wood, the USDA expects wood in the US, which is one of the biggest wood producing countries in the world, to the cost to go up between 35 and 46% by 2050. So that's a huge cost increase for wood. And the reason is that wood is being used more and more for energy production, particularly energy pellets, for example, that they're then sent to Japan or sent to Europe. So that wood supply, that residue, essentially wood residue, is not as available. And like I said, it's also when you have a biomass product, even if it's wood residuals, which is lightweight, unlike the big trees that you see on the trucks go by, you are limited to how far you can transport them. So there's a higher demand there. We're also seeing trees experience climate change. I mean, with the bark beetles, with fires, the firewood, they'll pull it out once it's done, but then you're kind of just decimated that supply after you take those burned trees out. So I am seeing more people interested in using a plant-based solution. What's critical in this, though, it's not like you can just go out and, I'm just going to grow this grass and figure that out. The supply chain is critical in that first thing people want is that readily available supply. It has to be consistently available, and then they want that supply of that material to have a consistent property. So the biochemical, thermochemical properties have to be very consistent because they're used to that in wood or with a plastic. And then they want to make sure that when they use that material in their product, that they have the same functionality in that product and also the same aesthetic appeal. Absolutely critical there. And yes, they want to be able to drop it right into their current manufacturing system, which is not as easy as it sounds, because different materials have different properties and they feed differently and so forth. And then finally, and I hate to say it, but the last thing on the list is sustainability. So if you can wrap that all up and provide that to them, then yes, we're seeing with that capability in-house for us, we're seeing the higher demand.
I mean, it sounds like there's in the process of selling the contract with the manufacturing, then there's a lot of scrutiny. Like they want to know really, look, how much can you get and how much can you store and how long does this stuff store before it needs to be processed? Like all of that must be incredible amount of work to map out. And oh, by the way, you still got to get farmers to grow it in a particular location that they're not quite aware of this possibility, right?
Right. So, you know, that of course, something new, putting some new plant in. Oh my gosh, what's going to happen with this plant? We actually are growing it in Europe, and we put it along row crops, and it does just fine because we're working with a large company in Europe on a big pilot project in particle board. But there are a lot of moving parts to this. You're absolutely right. And kind of what I really like is all these different variables that you have to deal with. Kind of my thing, but yes, there's a lot of moving parts when you're dealing with, it's basically what you don't want to have happen is someone has to change their light fixture to use your light bulb. And so for that, to use this new light bulb, it's got to be within this very narrow range of
variability testing.
Variability. Right.
That's the coolest thing about manufacturing. Or at least that's what I glamorize. It must be like, given I've been in, more of the IT world, so it's not quite the same concepts that I have to wrestle with. Like I think I used to do work for restaurants. We were making websites for restaurants, and I did it just because I was amazed and terrified at how they have to manage basically product that, is spoiling at a given moment at a certain rate. They're all the products at different rates, and you have to, like how do they do that? And you got to deal with like picky eaters and critics. It just blew my mind that anybody would actually want to do this. And it's just more of an appreciation whenever, it's done well, that you're just amazed at how they can pull that stuff off. Right.
That's a really interesting analogy, but I see why now you were asking earlier about the supply chain issues. Yeah, you get that. You get that. Yeah.
Yeah, that's the key to making a great product that it makes sense for a manufacturer, business owner to take a chance, right?
Right.
What are some of the other features? Like I was noticing you can create these into pellets. You had mentioned pellets before, but it sounds like, so they measure heat. So you use this in a chemical process. You need to heat boilers or something with it, right?
Right.
And then they measure how hot it gets as BTUs, right? It's got better BTUs than the same equivalent pound of wood per pound.
Right. So it's British thermal units is what BTU stands for.
Okay.
And we have British thermal units at a pound basis. And so our xanthograss is about 8,000 BTUs per pound, which is hotter than some wood, so it will burn hotter than some woods. And we're able to. The nice thing about grasses is when you want to pelletize them or even press them into the boards, they're naturally waxy. So that wax is really great for the binding process when you're pressing those pellets together. And it's also great because if you're making a board and then cutting a board, it actually acts as a natural lubricant. So there are significant advantages to using grasses that we're just sort of starting to promote.
So you don't so maybe you don't split the board when you're cutting it, or really.
Well, you might not get as when you're cutting a board, and you might get your blade might heat up a little bit and make a vibration. This allows sort of lubricant.
It's more like going through butter a little bit.
Cut. Yeah, a little bit.
That's fascinating. So what other areas are they are you able to find, I mean, it's sort of the fiberboard, the biofuels, these energy pellets. What are other possibilities that might be out there for your product?
Well, we actually are going to be testing concrete as an aggregate the
Concrete.
next couple of
Okay.
weeks. Yeah, with a
What is,
company
what is,
down in
why does,
California.
why does concrete need plant-based products in there?
Well, because to bind the cement together, you need some kind of aggregate. So it may be a sand, or you can use some rocks as well, depending on what you're doing. And you can use this plant material in place of it. So our fibers, formatted in a certain way, can go mix with this entire, everything gets all mixed together and actually lightens the concrete finished product. So you're lightening that product with the fiber, but you also are still retaining your compression strength, which is absolutely necessary for concrete. So,
What is there a trade-off for it though? Where's the trade? I mean, you don't have. I mean, you have to sell the product, right? But what are the trade-offs? Well, whenever you're mixing new materials with something else, there's going to be somewhere it changes the chemical makeup.
some kind of, yeah. And so that's what we are figuring that out now through our testing, which we'll do in the next couple of weeks. It's similar very much so to hempcrete. You may have heard of hempcrete, but they use hemp mixed concrete and they put it into walls and different things. And it makes for great insulation. And it's also a great encapsulator in terms of sequestering carbon, because you're not burning that material. You're actually putting it into a long-standing structure or some kind of decorative element, something along those lines.
So that sounds exciting to figure that out.
Yeah.
Does that involve like having to get outside consultants, or like how do you have labs, or how does that go?
Well, it's the nice thing is that when a lot of companies have labs, particularly companies that are looking to do sort of the next step, the next thing. So the company we're working with down in California, we supplied them with the raw material. And they have a lab, a little mini lab that they have on
so
site.
they're going to play with it and see what kind of.
Yeah. So and oftentimes we'll send, 20 pounds here, 100 pounds there, just to get people, to test the stuff in their material or in their new product. And so that's actually happening on several fronts right now for us. So we're at that proof point in a lot of ways.
Mm-hmm. And so then, okay, so I want to shift though a little bit into it, because your background's also fascinating. You had worked in IT, so instantly I had to have a conversation with you. You worked in IT for the Commerce Department, right? Back in a few years ago, I would say.
Yeah, just a few years ago. So that was as an advisor to the U.S. Secretary of Commerce and U.S. Trade Rep on international trade policy related to IT and communications and so forth. That was an executive level appointment, so we weren't paid, but it was like service to your country kind of thing. And so once a quarter, you go to D.C. and you talk to the people who are on the front lines of putting together the trade agreements. These folks are amazing long-term government employees who just do a phenomenal job. And basically, we were there to help guide them as they were writing these trade agreements, and whether they're multilaterals or bilateral trade agreements with the different countries. I did some IT work when I was in graduate school, and then came out of graduate school and started my first company, which was helping educators integrate technology into their curriculum. So I've done some programming and stuff, and not my favorite thing to do. But from that was the perspective that I came at it from when I was nominated and then appointed.
So it was more it was a policies around education, trading technology over education sector, or?
No, it just that I had done it, and it was very much trade policy. So whether or not, what tariffs might be on different services, how to prevent having those tariffs, saying, oh no, well, we're going to have a free exchange of consulting or any kind of service providers, such as just, like your internet service provider, those kind of things. So working with other people that were from AT&T and Verizon and IBM and Oracle and so forth, kind of everybody brought their expertise to the table.
Wow. Well, I can tell you one thing, the education technology sector needs a lot of work. I've got front view with my kids.
Yeah, I'm with you in that boat.
It's like Blackbot. I'm going to call them out on my show, but Blackbot, you did the focus groups with college kids. You didn't do it for kindergartners, and those buttons can't be icons. I had to listen to a Spanish teacher aide try to explain which icon was the microphone because it wasn't very clear. So anyway, I got a long rant around that I'm just I don't want to derail this episode on that, but there's still a lot of ground to cover.
I feel your pain there.
Yeah,
I feel your pain. I believe me. Yeah.
This is just, it's just interesting, your career path through this. And then after that, you worked a little bit with hemophilia as a director of research. I mean, how'd you get into it? Do you just kind of decide, okay, you know what, I'm done with the education, advising the government on how to do things. Let's check out this place.
Well, the government advising was concurrent with all of this stuff.
With all that, okay, right. It wasn't full time.
Yeah, so
okay.
But yeah, so I did my little business, which didn't work out. So I was sucked into a family business that focused on materials engineering and patenting of advanced composite engineering. So I helped run that for a while. And then I just decided, I need to kind of step away from family. And I got into hemophilia, bleeding disorders, really in general, more like that. As from more of an advocacy perspective. So because I had done so much work in the government and grew up outside Washington, D.C. and, really understood the whole thing. And then just from there, that was in New England where I started, and then we moved out here out west, and I got a new job as the director of research for the Hemophilia Federation of America. And ran a 5-year study with the CDC and did some work with PCORI and got grants from there. And one of my main focuses was on basically translating the technology, the underlying new medical advances in bleeding disorders to our layperson audience and to our patients. It was wonderful. I have to say it was awesome. I love that community. They're just delightful. But I did a ton of data work as well with that. And then just kind of got to the point where I was ready to go back out and do that entrepreneurial thing again. So.
And so what made you jump back into the biomass, biofuels, and plant-based products, this area?
Well,
the history.
Yeah, it's funny because a friend of mine in son has hemophilia introduced me to a company that was looking at doing something similar. They've been around for a while, and I just got fascinated by the idea of, oh my gosh, you can use plants to replace fossil fuel based feedstocks, and because I'd done so much materials engineering, I'd been in that whole world. We were working with Textron, and we were working with the Army, we were working with Stanley Tools and so forth. So I've been in that materials world and understanding the supply chain and such. I thought, oh, well, maybe this will be something cool to do. And then with the biotech background that I sort of gained in the hemophilia space, and also at one point in time, I was with a small gene therapy company that was working on hemophilia A. And so I, learned, sort of just picked up, I just kind of learn as I go. Just kind of suck it all up. And I thought, okay, well, we can look at it from both the perspective of it being a biotech, understand the thermochemical, biochemical, physical properties of this material that we could potentially use as a substitute. And that's how I came at it. And I thought, this could work. This could be something that happens. And the timing seems right. And businesses are all about timing when this stuff is. So.
Yeah, it just seemed like there's been, I don't know how you would characterize this world that you're in, but it seems like people are more open to testing alternatives, right? Versus before it was like, oh, the presumptions are alternatives will always be more costly, too much trouble, and we're too busy anyway doing what we're normally doing, right? But I think businesses and manufacturers and everybody are starting to notice you can't count on certain things forever, right?
Right. And I think, like you say, and particularly the past few years, maybe the past 5 years with hurricanes and flooding and fires and so forth, we have these precious resources that we need to maintain. And I think we're really not at the point of sustainability because we can't sustain where we are now. We actually need to move to regenerative And that's why I really was fascinated with these plants, is because they are regenerative. They allow us to go back and repurpose land again for food crops, which we know is going to be a huge issue, and feeding the number of people we'll have in this world is an enormous issue. And it's a shame that we have to be in this position, given that 1976, National Geographic had an article on the tipping point. We were either going to go too hot or keep our temperatures down, and that was in 1976. And so, unfortunately, because I think there were certain groups that still made a lot of money off of fossil fuel and so forth, we are where we are today. So
right, it's just momentum, and it's just difficult to make change sometimes, right? And they don't put a street light until somebody has an accident at the corner, right? That kind of scenario that we seem to always operate under. But it's also kind of exciting, because I just think that I keep hearing it's much more sophisticated than it was 10 years ago. Mm-hmm. And it seems like there's so much ground to explore, because you're just learning about what you can do with these grasses. There might be some interesting properties that come out of these, these potential partnerships, and you just gotta play with, you just gotta test it, play with it, right? And see what happens.
I mean, these plants also produce, from the liquid that you can extract from the plants, we found some fascinating characteristics. So, and it's
like what? Can you give us an example? Put you on the spot.
Well, like our xanografts produces a natural antifreeze. And it produces really high levels of humic acids. And so, it can be used for all different kinds of things. And so,
what are those acids used for? Like, what are they?
So biostimulants. So for helping other plants grow faster and better, and being 100% natural and organic versus using chemical fertilizers. So some people like biochar, and some people mix the biochar with fertilizers. But we could actually just pull all the yummy stuff basically from the plant.
Squeeze it out as you're drying out the plant product, and you can repurpose that. So you're just sitting on this like potential. I mean, how do you protect the material investment? Is it like, is it something you can patent along the ways, or like you patent the process involved?
We can patent the process. We can, in the U.S. you can patent plants.
Okay.
And then internationally, you can patent varieties of plants. So, they're not patents; it's actual intellectual property protection that you can get for varieties. So, our xanograss is a set of varieties of the giant perennial grass that we use, and so we are in the process of establishing our varieties and therefore our intellectual property associated with them. Again, that's one of the reasons that we supply the plants to the farmers, so that because our varieties that we choose are very high yield. They maybe grow very well in salinated soils, which you see even in the middle of the country. They used to grow corn in Oklahoma and northern Texas, but they used up all that groundwater. So that ground has become very salty right now. And so they can grow cotton, but they can't grow a whole lot else. So if we have a plant that can go in and do that, then we're going to have that as one of our varieties.
I see, to help replenish the soil. I mean, that's part of the characteristics. So you're trying to sell it to two buyers, really, the farmers, in a sense.
In a sense, yes, exactly. So it's with the farmer, if you're talking about not just regenerating the soil, but if they have something like chemicals that are in the soil or heavy metals, this plant will take up those heavy metals and chemicals and truly remediate that soil. So that you can go from having a Superfund site to having an actual site that you can build on.
You actually grow something on.
Yeah. And so it's these kind of multiple efficiencies that you get from trees. I mean, trees are you get the high oxygen production, and you get shade, and you get a wealth of other benefits from trees. But where trees won't grow, or where trees will take 30 years to grow, and we're harvesting every year.
There's the supply. There's the rotating supply in a local area that you might not be able to get enough forest to do a staggered. Okay.
Right.
Whoa, that's pretty awesome. Um, so Wendy, then, well, we should ask about your other business. I mean, that just seems like this is the full-time gig, but then you seem like somebody that just can't stay still, right? I
No,
mean, let's
not
add
really.
another business. What's that one about? What's Biomass One about?
So one of the things that I realized in working with our customers and then just existing as Hexas is that there is no single place where you can go to, or even multiple places you can go to for me to find farmers to work with. It's an arduous sort of process. It takes days.
Yeah,
And then on the
drive
other,
out there.
well, you have to figure out, okay, well, talk to the local agricultural commissioner, and talk to the farm bureau there, talk to, there's lots of
Meandering process.
and then
Okay.
you have to find the right farmer who's ready for this. I have to say I love farmers because they're totally entrepreneurs. They are way over the top from me too. So they're always like, oh, what's new? What are we going to do? So that's one challenge. And the other challenge is then if you are a company that wants to use biomass in some way, plant-based biomass, wood, so you then have to figure out, well, where do I go to get it?
Mm-hmm.
Who do I talk to? How much does it cost? How much should I pay? How do I get it here? And so seeing that, I said, oh, wait a minute, we've got to create a marketplace. There's this, much like Zillow and Redfin have said, oh, no, we're going to bring that whole real estate marketplace together and make it simple, where you can be sitting on one side of the country and buy a house on the other side of the country. Very much along those lines. Now, houses have lots of different variables, right? So there's lots of data associated with the house. And there's lots of data associated with biomass as well. So whether it's hemp or flax or xanograss or switchgrass or almond shells or almond hulls or rice straw, all these different types of biomass that you can use, they also have a significant amount of data associated with them, which are the biochemical, thermochemical, and physical properties. So we are using, and my co-founder, Brian Dolan, who is at Verdant AI, we are using artificial intelligence as part of our driver. And the reason is that most engineers, material engineers that would come in couldn't say, well, I really need to use CNEF as the plant. Because we don't use plant-based stuff, right? If they would say, oh, I need this kind of plastic or this kind of, or that, or then that's easy. So you kind of have to reverse engineer into it. So thinking like them, if we then say, okay, you need to search by the properties that you
That's
need,
what I was, right.
Exactly.
Tell us the properties you're looking for. And then you use the neural network to figure out what have other people connected when they searched for those properties and they actually looked at this company or that company. You're tracking that and then trying to see if you can improve the probabilistic search rank to define the product. Like you can't yourself read all the properties and then categorize them and then put them into these forms and then track who's actually connecting with the manufacturer, farmer, product. It's just too many variables, right?
Right. So we have access to our we have properties, and we're having those.
That's your taxonomy, right?
So,
of what you're limiting, and then you're trying to see if there's connections just from people using the system.
Precisely. So, but it allows people also then to say, okay, I want something with this level of C5 sugars, or this. Or maybe I don't need a lot of ash, or maybe I need a lot of silica. And so you can, based on those parameters, you can go in and you can search and say, you back into, oh, well, here is a list of plants that potentially can meet your needs. And here are some farmers that are, growing that and have rice straw or wheat straw, or maybe someone has the post-processing of a meal, like a corn meal or a flax, and they're located here, and you can get it back. And then we help them with the contracting. So we'll have online contracting as well. And then also with logistics for delivery supply chains.
Because that's half the problem is surfacing like what farmers are actually producing the stuff. You could have a farmer just down the road already doing the product. And he's just waiting for another customer to pay him more so you could expand to the next field he has. But it's hard to know unless there's some place that's helping drive those connections. And it can't just be a forum with people it could, and that's kind of the way most people on the internet, Google and some forum and asking your buddy down the street, but it doesn't seem efficient, you know?
Right. It's not efficient, and it couple that with the inefficiency of our agricultural residue, which becomes agricultural waste, and the inefficiency of, if we produce a ton of rice, we have a ton of waste, and so that waste used to be burned, and now it's just flooded and rotting. And so what do we then? If you look at plants as nascent fossil fuel, essentially, because eventually, once they, for millions of years gets pressed down, they eventually will be crude oil right there in the ground, right? Mix some animals in there. But if you look at it from that perspective, the properties, the underlying chemical properties are already there. The elements are there within these plants. So, and we produce a lot of it. We have so much waste. It's an incredible amount of waste for, different shells and stalks and various things. Why don't we make use of that? Why don't we make this an efficient system where we are actually fully circular and using all that we produce and all the energy and input and everything we put into this stuff? Why are we just letting it just languish in the field, or why are we having people burn it?
Yeah, it seems to me that there's just undiscovered properties that we haven't even figured out, because no one's had the time or thought through like what to do with the waste. It's just cheaper at the moment to just dump it and back into a landfill or whatever they do with it, right?
Yeah, and in the United States, we haven't caught up with Europe. In Europe, you can sell your agricultural residue for 50 euros a ton. And that's good money. I mean, it's really good money right there, because they're using it for energy production and kind of locally in one place or another. So where they may not have as much solar or wind production, there's biomass relatively easily available. India, they're doing a lot of that. So
but in Europe, I guess there's they're more squeezed for land, right? So they're more willing to experiment with reusing. Like, what do we do with all this soot that comes out of this? Whatever thing. There's something we can do with it, right? They're more willing to probably think about that. But in the United States, we're just the land of acres here.
Yeah, we've got land and trees.
Yeah, and that's an issue, right? Because getting these materials to the location is part of that's part of the other business of solving, right? It is a big giant country, right, to figure those
right. So but we can create jobs with the more efficient use of our resources, the energy and everything we put into the production of food, and then using it afterwards. But like you say, it rots, it changes its chemical and biochemical properties after a certain period of time. But these are all things that I don't think we have much choice but to figure out now.
We have to work on it. Yeah.
I mean, I think we can, and we have. We collect that data, we use the artificial intelligence, we run modeling, we're able to, I think we can get way out ahead with just not having to go and plant and wait a year and plant and wait a year. I think we can really get out ahead here.
And if you can make a bag of concrete lighter, even just a little bit, that probably would save a lot of bags for people.
It would save, and you think about transportation costs, transportation costs and so forth. So really focusing on the multiple efficiencies that you can achieve with what we're already producing,
it
like
seems
recycling
so cool.
clothes, right?
It's like you're looking in these sort of nooks and crannies at the moment, but could potentially explode just because of all the external pressures that are coming upon having to actually be more thoughtful about what we're doing. It just seems like it's a great time to get into this world. If it may be late, maybe you might be late if anybody's out there thinking about it. I mean, it just seems there's a lot of potential interesting novel applications,
Yeah, and a lot of people are doing processing, but I wanted to start with raw material because that's where it all starts. That's where the rubber meets the road. And I find that people will come up with a great process for biomass to create energy or to create one thing or another. And the last thing they think of is accessing the biomass. How am I going to access it? What kind am I going to access? How does it need to be processed? What format does it need to be in? Because when you're working in sort of a lab situation, it's very controlled, right? Oh, I'm going to go out and I'm going to get X number of tons and have it sit over here, and maybe it's wood and it stores well. But wood's not everywhere. And what if you want to do something in the Great Plains and you're not going to have a bunch of trees that you can draw
Yeah,
from? So, yeah.
the true effort of designing a product is not the designing of the product itself, but it's the manufacturing process to get to the final end product. This is a great idea. It's how do we do it in the environment that we're in the business challenges. I mean, Tesla's
Right.
a great example of how hard it can be to figure that out,
Yeah.
and
even though they had a model to based on, they have a model that they're working from. And I would say that I have a model that I'm working from. I also often think about GE Plastics. They had the variety of different plastics that work in different formats and different applications. And still, despite having the model, or wood or bamboo. Bamboo is also another great model for this. So, yeah.
Right. Well, half the challenge is you get a business model that you think there's a big customer base, and then your customers tell you really if the customer base is there or not, right?
They do. Yeah.
They start to tell you where I need this thing to be, and it's not what you've envisioned, right? But that's part of that process, and I think it must be pretty satisfying to take a chance and stake a claim into that world. I think a lot about business is just getting the opportunity to work around interesting problems. Like what more can really ask for or hope for, and make a living, of course, doing it, right? That's kind of sustaining the process, right?
That is the goal eventually.
That's the goal.
Well, like the grass that we grow, we can plant it just about anywhere, and which is a nice thing. So was also very critical, is that you can't have something that grows just in a couple of locations in a couple of different ecosystems. You really need something that can widespread, and we can use 100% mechanical planting and 100% mechanical harvesting. Whereas like bamboo, for example, you have to cut by hand. You can't just go in and mow it down.
Bamboo is crazy strong. I have neighbors that have bamboo forest, and they started cutting it down a bit to trim it back. They didn't even make a dent of it. It was like halfway into it. I think the contractors gave up. I have a water runoff cement concrete between the properties, so I'm not too worried about the bamboo sneaking into my property, but it's pretty amazing material. But it's cool to know that there's just a plethora of other plants. I just haven't even probably looked at it. How did you land on this type of plant though? How did you come across that one?
Well, like I said, a friend had introduced me to a company that was doing something similar and had been looking at that plant. And I thought, well, I can do that. So, focusing on that plant. But I have a list already of other plants that I think in some ways could be better than this plant too. So, and miscanthus is another plant that we grow, and it's been produced very well in Europe in cooler climates. It doesn't have quite the yield or the multiple applications that our xenograss has, but it's still an excellent biomass product. Both those grasses that we grow are EPA approved bioenergy crops, so they meet the renewable energy standards. And so it's all these different variables, right? I looked at a bunch of other plants and landed on these because they meet the variables for that end product, that end customer. They have some underlying certification associated with them and so forth. So
it's not something totally off market that you just now have to educate a new market to understanding. There's already inroads with it.
Yes. So the USDA's looked at it, the EPA's looked at it, the Department of Energy. So it's not having to be like this brand new from outer space sort of thing that you have to introduce. People are familiar with it. People, really about 10 years ago, tried hard to push for plant-based products with the same kind of perennial grasses. So there is a significant amount of experience. There's a significant amount of field projects, and there are successful projects too that came out of it. So I'm kind of standing on the shoulders of giants that people have become before me, and able to read their research and see what they did and so forth, and learn from their successes and their failures. So
right. So much is also timing, right? Timing to a marketplace that's ready and receptive versus novel idea. Definitely something everybody would need, but nobody is ready to do the research on their own, right? And that's just,
Right.
yeah. So I just think I mean, companies like yours are exciting. I think it's positioning themselves for the future, and I wish you the best of luck. Do you have any of these plants growing in your home by chance, like as a
Not, but I have them. Yeah, I can show you.
Oh, okay.
Yeah. So this
That's the
is
spot.
one of the pieces of dried pieces, and it's I know you can't see all the fibers, but they're in there. We then have produced particle board from our plants. I've got all sorts of stuff. I just didn't bring it all around. So yeah, so this is the board. We tested it. It tests beautifully for specific particle board applications. I pictures on my website, I guess, is the one place to look for that. We harvested already this year, but we will harvest in Europe probably more in the springtime.
Let's plug the website, hexas.com, HEXAS.com, if anybody's interested in learning more. And just curious on the technology stack for the other company, where are you going to go? Microsoft? Are you going to open source it? Or what are you going to do?
That's the question for my co-founder.
All right.
Yeah, I have to say that is not my expertise. But
he'll take
Brian
the tech side. Okay.
Yeah, Brian. I mean, I have some. I can listen and I understand the words that are coming out of his mouth for the most part. But he is the brilliant guy behind the whole AI and how we're gonna run this thing. So.
Yeah, when you guys get up and running and you have something beta product or something you're gonna reach out. I'd love to have you back on and we can talk about it. Maybe talk about it with your partner there.
Yeah.
And kind of dive into it, because that sounds like you're beginning to be the future Elon Musk, perhaps, because that's like, next year you'll spin off the third company and then we'll see.
The next one. Pretty soon we'll be growing plants in outer space and things like that.
Why not? We need plants up there. Nobody's going to go to Mars without a plant or two.
Yeah, no, it's exciting. I'm excited. I'm happy. Thank you so much for this opportunity. I really appreciate it.
Yeah, Wendy, of course, this was super cool. Thank you for sharing and taking some time with us and sharing about the interesting areas. And yes, let's keep in touch, please. Definitely. I'd love to have you back on the show, especially as you get more and more feedback on the product. So don't go away. But you guys listening or watching on YouTube, I haven't talked about my YouTube channel. So if you did stumble across this and you've watched the whole thing, that's pretty awesome. Thank you. We're just starting the YouTube thing. But we'll see. We'll just keep progressing. I appreciate you guys very much. Take care. And that's it. See you later.
For more episodes of Through the Noise, go to throughthenoise.us.